What's poppin', dogs? Mr. Allen here with some non-right triangle trig. Now we got in triangle ABC, the measure of angle A is 71 degrees. The length of side A is 5. Now that's the side that's across from angle A, hence the upper and lowercase letter thing. And then we got side C has a length of 14. Solve for all missing sides and angles. Sometimes they'll just say, solve the triangle. Okay, so let's draw something up. I'll do my best here to draw a decent triangle. I don't know if it's exactly accurate, but we got a big 71-degree angle of sorts, something like this maybe. Whoop. And then I'll come down here. Okay. Sometimes they look kind of equilateral. I try to draw them as non-equilateral as possible. I kind of did a little equilateral there, but whatevs. Do your best, and then fill in the rest, if you will, with the information here. 71 degrees. Across from A is going to be the 5, and then across from C is going to be the 14. Now, you may be thinking, you're like, it seems a little too small. 71 degrees is probably one of the bigger of the three angles there. Maybe not the biggest, but it's definitely a sizable angle. Is this going to really work out? And that is a question you have to ask when dealing with an angle side situation. Right? The angle's not between those two sides. The sides are outside of it, so it's an angle side situation, which means we could have 0, 1, or 2 triangles here, guys. All right, so there's a bit happening. Well, let's set up law of sines and figure it out. Okay? And why did I pick law of sines? Well, law of sines is used when I have an angle and a side across from each other. It's the easiest one to work with, just a big old proportion. The times where I use law of cosines is when I don't have an angle side pair across from each other. Okay? So we will set it up, and you can either do sines in the numerator or sines in the denominator. It does not matter. At least I don't think it matters. The math works out the same. There might be some mathematical purist out there that says, well, you have to do it this way. I don't know, bro. All right. So sine of 71 over its side, and then we'll call a sine of C, sine of angle C, over its side of 14. And now I can cross multiply and solve. So to do that, I'm going to get 14 times sine of 71, 14 times sine of 71 equals 5 times the sine of C. Well, 5, try that again, 5 times, oh, it's terrible. I made it worse, sine of C. And then let's get sine of C by itself here. So I'm going to divide by 5 on both sides. We got to be careful with our algebra, be as accurate as you possibly can. So I've got 14 times sine of 71 over 5 equals sine of C. Okay. Now, how do I get C by itself if I've got sine of C? This is where inverse trigonometry comes into play. When I'm solving for an angle, use the inverse. Remember that from right triangle trig? Well, same applies here. It's just it usually comes up algebraically. So I'm going to take the sine inverse on both sides. That'll cancel out that sine, leaving me with just C. And then over here, I have sine inverse of all of this junk right there. I can actually type that all in at once. I am going to do it separately for teaching purposes here for just a sec, okay? I'm going to type in everything that's orange right here first. 14 times the sine of 71 divided by 5. This is okay. You can also type it in as a fraction. 14 times sine of 71, close your parentheses, arrow down, divided by 5. I get the same thing, okay? Make sure you're in degree mode, right? If you hit mode right now and yours says radian, you need to change that to degree, 2 down and 1 to the right. Hit enter on degree, go back, type it all in, okay? It's got to be in degree mode when you're given degrees or you're asked for angles and degrees. Most of like algebra 2, geometry, and pre-calc is done in degrees. Eventually make that switch to radians in pre-calc for some of the units. So it's a mix in pre-calc, then calculus is all radians. It's probably more information you want to know. All right. So now I would take the sine inverse of that. And the reason why I typed this in is so you could see that number there, 2.647 and change. Sine is opposite over hypotenuse. That's its ratio, right? And hypotenuse is the longest side. So if I take a number and divide it by something larger, I should get a number between 0 and 1 if we're talking all positive numbers. This is 2. This is going to be outside the domain of that sine, which is why I get an error, okay? So if we go to, it's because I can't take the sine inverse of a number larger than 1. It's not going to work, okay? So no triangle. No solution. Very good. Okay. No solution. or 0 triangles. All right. We drew it. It just actually really doesn't exist. This side would like end here. It wouldn't be able to connect down at C. So there's no triangle here. This is the 0 triangle situation, which is like honestly the best one because then you're done. When you get that twofer, when you get that ambiguous case with a 2 triangle, oh my God, it takes forever, man. I got to be real organized on this board and pack everything in really tight. But this one, I can see the future, no triangle. But that's what happens. It will work out that way. Like your calculator will tell you no solution, right? Which is nice. It tells you. But you still have to do the prior math correct because your calculator is only as smart as the person that is operating it, all right? Remember that. Calculator, only as smart as you. All right, that's it, guys. Thanks for watching this video. Have a wonderful day and stay awesome.